Good evening all. So in this video we will study the last type of the resistor, that is parallel in parallel out shift resistor, PIPO. Okay, so in this shift resistor what we will see that the data will enter into the resistor simultaneously across each flip-flop and will come out simultaneously at the output of each flip-flop. Means just supply the data at the input of each flip-flop and you will get the data at the output of each flip-flop. So this is the most easy and fastest, you can say fastest type of resistor, because as you supply the data across all the inputs, after applying one clock pulse you will get the data out. So first we will see the the construction of parallel in parallel out. So let's say we are taking 4 flip-flop, we have to shift 4-bit data. Okay, like we are taking from the very first resistor as 1101, flip-flop A, B, C, D, and D inputs, QA is the output, D input, QB is the output, D input, QC is the output, and D input, QD is the output. Okay, and they are triggering on by the same clock pulse. Okay, this is the clock pulse. Now we have to supply the data in a parallel way and we have to get the data in a parallel manner. Means supply the data in a parallel way. Means here we are supplying externally the input value externally, like P0, B1, B2, B3. I know there is one question that definitely arises in your mind, that why we have not used the combinational circuit arrangement between the two succeeding flip-flops. Between the two successive flip-flops we have not used any interconnections as we have done in the case of parallel in serial out. But we are not using any interconnection. All the flip-flops are free from each other. As you supply the input, you will get the output separately. You will supply the input, you will get the output separately. Because in this case we are not supplying any interconnections, because we have to get the data out parallelly, not in a serial way. If you have to get the data out of the flip-flop one by one, then only you have to supply the interconnection. But here we have to get the data in a parallel way and you have to get the data out in a parallel way. So each flip-flop will be independent from each other. They are just connected by a single clock. That's it. Otherwise QB is not dependent on QA in any way, not in terms of input, not in terms of output. Okay, so once you supply the B0, when it get the trigger, QA will appear here. This is QA, QB will appear here, QC will appear here, and QD will appear here. So this is very simplest resistor and very fastest, because as you supply the data, for example you are supplying 1101, so as the positive clock reaches to each flip-flop, all the flip-flop will get on, and now in this case the B, C, D flip-flop are not dependent on the output of QA. They will produce their own outputs because these inputs are appear simultaneously. So 1 will appear here, 1 will appear here, 0 will appear here, and 1 will appear here. Now as you supply the input, you will get the output. So you will get the output simultaneously 1101. So just after applying the one pulse, you will get the output. You will store the data and you will get the data. So just after applying the one clock pulse, you will get the data. So this is the fastest resistor that we generally use in computer organization, because as you supply the data, you will get the data across the outputs. So this is the parallel in parallel out shift resistor. Thank you.